So we're going to introduce the concept of one of the fundamental properties of matter, charge. We started off the class with a demonstration where we got a shock because we charged up a static generator. So what we want to understand is what exactly is this charge, where does it come from, and what are its effects on other charges. A lot of this should be familiar from chemistry, but we're going to build from scratch because it's going to become important for not so much what charge is, but what it does, namely forces and then ultimately energy. Okay, so this is the ground floor. So when you charge something up, like when I peeled the tape, it became charged. When I rubbed the wands with the fur or the plastic, it became charged up. So where did they come from? Well, I didn't create them from nothing, which implies that they were already there. So if we ask, well, what are they a part of? Well, they're a part of everything. Okay? And you kind of know this from chemistry because most everything is made up of atoms, and you know that atoms have charges in them, namely the protons and electrons. Okay? And so if everything has charges in them, why don't we get shocked every time we touch something? Well, because normally all objects are electrically neutral. Okay, so most of the time you touch an object, be it a door, be it a person, a wall, the floor, you don't get a shock. Yet all the charges are there. So why doesn't statement 2 contradict statement 1? Well, again, this is building what we know in chemistry. That's because there are two types of charge in nature. And they give us exactly opposite effects. And because of those opposite effects, they almost always come in equal numbers. Now, the equal part's not obvious why that should be, but you learn that all atoms are electrically neutral. If there's 10 protons, there's going to be 10 electrons to keep it neutral. If you add 2 more electrons, you don't have an atom anymore. You have an ion that has a charge of -2. But if you leave things alone, they will almost always go to neutral, equal amounts of positive and negatives, for reasons that I'll talk about in a few minutes. Okay, so if things are electrically neutral and then they become charged, well, what happens? So what's going on when we peel tape or if we rub a balloon against something and it becomes charged? Well, if they're already there and then if something's charged, that means they have more than they did before. In other words, there's more negatives than positives or less negatives than positives. That implies that there was a transfer of charge. So in other words, what gets transferred is always the negative charges. The electrons. Electrons are the only things that can be stripped from one body and placed onto another. You can never be the negative. So it's transferred, okay, so not created from one object onto another. Okay, so if I rub the rabbit pelt onto ebonite, one gains electrons, the other loses electrons. You can't just charge one thing without something else becoming charged. Otherwise, you'd be creating it from nothing. So the object that got the electrons taken away becomes positively charged, and the one that got negatives transferred onto it becomes negatively charged. So we want to understand that the overall charge of the system hasn't changed, but we've added negatives to some, lost negatives to the other, which is positive. So if the overall charge of the system doesn't change, then that implies a conservation law, or the law of conservation of charge. You cannot create or destroy it. You can only shift it from one body to another. Okay, now why do we care about, or how do we know when something becomes charged? Because there's forces that we can see. We saw the tape being attracted to the finger, or the tape being repelled by one of the wands. So that force is fairly strong. We'll talk more about that in the next lesson. All right, but here's what we do know about charges, and these are based from observations we saw in class. Like charges always repel. Okay, opposite charges always attract, and you should remember that from chemistry. What is less obvious is what happens when you have a charged object, be it plus or minus, and a neutral object. Okay, they do not ignore each other. Because the neutral object has charges in them, they will respond to either one or the other charge, and they will always respond with an attraction. Okay, or always attract. So it's this last part right here that explains why atoms always move towards neutrality. If I have an atom, let's say I have 7 protons, and surrounding it I have 6 negatives, right? That's going to be an overall positive 1 charge. Well, if there's any electron that's straying by, it's going to attract it such that they neutralize. So the neutral atoms and neutral objects is not an accident. It's because opposite charges attract, and so they're always going to keep attracting until they're equal amounts. And if you want to make them unequal amounts, you have to put in energy to the system, and that's kind of where we're going to be going next. But before we get there, we got to learn how to quantify charge. And talk about how much of this, how much charge we have in a balloon or a static generator. And it's going to be different than what you learn in chemistry. We're going to talk about a new unit called a coulomb. So I'll leave that for the next tutorial.